Okay, so before we call it a day, so to speak, I just wanted to give us a chance to take a look at a couple of practice problems, just to make double secret sure that we really know what's going on with the rate law. So let's take a look at these two here that I've already got on our little whiteboard. Number one reads, in the reaction A plus 2B gives us C, they tell you that the rate law has been experimentally determined to be rate equals K B to the second power. Now remember again that you can't just willy-nilly go saying that the rate law is any one thing, right? The rate law does need to be experimentally determined unless we know that we are looking at the what's called the elementary step, or the sort of slowest or limiting step in the reaction mechanism, right? So in this case, they've told us straight up that it is K B 2 for this reaction, for A plus 2B gives us C, yeah? Now we know that K is what we call the rate constant. And because it's constant, it's not necessarily relevant to this discussion. But this bit here about the B is sort of interesting to me, because normally we think of the rate law, we think of the rate constant of being essentially as follows. A plus B. So this equation right here should give me a rate law of A and B, like that. Again, assuming that this is the limiting step. Right? So the fact that this guy over here isn't mentioning B, here, let me change colors. The fact that this guy is mentioning B but not A is interesting to us, right? Because normally for this equation, this should read R A some guy, right, plus B 2, right? So in other words, all this tells us is that this whole thing, this whole sort of A to the A must give us 1, right? And we know that the only thing that'll really give us 1 in terms of this equation would be if whatever A is was somehow put to the 0 power, right? So in other words, when you see a situation like this one, where you have an equation where there is clearly an A reactant, but A is not listed anywhere in your end equation, essentially what that means is that A isn't relevant, right? In other words, the amount of A that we have here is not relevant in terms of the rate of the reaction. So the concentration of A, because we know that A is to the 0 power, we essentially know that the concentration of A is not going to affect rate. So if we look back to our original question, they're asking you, what's going to happen to the initial rate of reaction when the concentration of A is doubled? Well, again, it's not going to do anything. It's not going to affect the rate at all. So my answer here must be D, the rate is unchanged. Okay, phew. So let's take a quick look at number 6. Based on the reaction mechanism shown below, which of the following statements is correct? Okay, well, you might remember this equation here from our initial conversation. Oops, sorry about that. Having to do with, the reaction mechanism, right? So again, notice the pattern here in terms of the answer choices. They're asking you whether, which of these is the rate determining step and what the rate of the overall reaction is. So let's start with a rate determining step. Remember, the step that always determines the rate is whichever one is happening most slowly, right? Remember our dishwasher example? So it's going to be this one. It's going to be number 2. So we can get rid of A and B, and that leaves me with either C or D. Okay, so now remember we said over here that when we're looking at rate, one of the things that we're going to be looking at is, for our limiting step, right? What do our reactants look like? Well, we've got essentially we've got 1 molecule of N2O2 reacting with 1 molecule or mole, or however you want to think of it, of O2, right? So for this equation, that would give me rate constant K, N2O2 to the 1 power, right, which again is just going to be N2O2, times O2 to the first power, which again is just kind of O2, right? So if we look here at our 2 options, clearly the answer is going to be D. Okay, it's also worth noticing, guys, that these problems that I pulled are actually from the MCAT exam, the medical school exam, rather than the ACT. So if these felt a little advanced, that would be why. Again, when in doubt, I'm always going to go for more challenging as opposed to less challenging, because it'll be a pleasant surprise to have easy problems on the SAT. We don't want the nasty surprise of problems that feel too hard, right? Okay, great. Thanks for listening, and I will see you next time.